Hello, welcome to class. Today, we're going to be exploring the concept of simplification of surds. Now, let's get into the class. To simplify surds, what we do first is to express the number under the square root sign as the product of two factors, one of which must be a perfect square. And then from there, we can now simplify by taking the square root of that which is a perfect square. I want you to note this because this is the principle behind the simplification of surds. We say to simplify surds where possible, because there are some times where it is not possible to simplify a surd. I want you to take note of this. So to simplify surds where possible, we first express the number under the square root sign as a product of two factors, one of which is a perfect square, and then this we can now simplify by taking the square root of that which is a perfect square. Now I want you to note something first about the perfect square. What are perfect square? Or what is a perfect square? A perfect square is simply a number such that when you take the square root of it, it will give you a whole number. A perfect square is a number such that when you take the square root of it, it will give you a whole number. For instance, 4 is a perfect square because square root of 4 gives you what? A whole number, which is 2. Another example is that 16 is a perfect square because the square root of 16 gives us what? Gives us what? 4, which is a whole number. Example again, 9 is a perfect square because the square root of 9 is what? Is 3, which is a whole number. I want you to take note of this. A perfect square is a number such that when you square root it, you will always get what? A whole number. Okay, let's take some classical examples to illustrate what we've just explained. Now the question here is, simplify the following. Remember, to simplify means to bring it to the lowest form, to the simplest form. Okay, the question says simplify the following. Number 1, square root of 45. Then number 2, square root of 32. Then square root of xy square. And then square root of 50. Now let's solve this together. Square root of 45. Now remember, the rule says to simplify a surd, we are going to look for two numbers such that when we multiply, will give us 45. Then at least one of the number must be a perfect square. So you can see 45, we can have what? 9 times what? 5. Because 9 here is the perfect square. And then from here, we can simplify further. Remember our rule that we stated that square root of m times n is the same thing as what? Square root of m times square root of n. Remember this rule, right? So we can still apply it here to have what? Square root of 9 times square root of 5. So square root of 9 will give us what? 3 times what? Square root of 5. So 3 times square root of 5, this will give us what? 3 root 5. So this is the simplified form of square root of what? 45. I hope you understand what I just explained. Okay, let's look at the second example. Number 2, we are asked to simplify square root of what? 32. So this is it, square root of 32. So we're going to look for two numbers such that when we multiply, we'll get 32. At least one of the number must be what? A perfect square. Now, and I've told you perfect squares are numbers such that when you square root them, you will get what? A whole number. So now if you break this 32, we're going to have what? Square root of what? 16 times 2. Because 16 times 2 gives us 32. And then 16 here is a what? It's a perfect square. So now, simplifying this, applying this our rule, so we can get something like this. We can break this to square root of 16 times what? Square root of 2. So now, what's square root of 16? This is what? 4 times what? Of course, this is a surd. So we leave it there, square root of 2. So this will give us 4 times square root of 2. This is what? 4 root 2. I hope you get that. Okay, number 3 was square root of xy square. Now for number 3, square root of what? xy squared. Now, so we can break this to have square root of x times square root of what? Y squared, because y squared here is a perfect square. Now, simplifying this, so this is x times square root of y squared is what? Is simply y. Now, of course, you can see that this can cancel it. So that's why we say that square root of y squared is y. So square root of x times y gives us what? Y root x. Y root x. And that's the answer. I hope you understand that. Okay, number 4. We have to simplify. We are asked to simplify what? Square root of 50. Now, when you break down 50, we will have what? Square root of what? 25 times 2, because 25 here is a perfect square. Now, so this is equal, so this is the same thing. Can say this is the same thing as what? Square root of 25 times square root of what? Of 2. So now, square root of 25 is what? Is 5. And then 2 here is a surd, so we leave it there, times square root of 2. So that will now give us what? 5 times square root of 2 gives us what? 5 root 2. And that's the answer. So this is the simplified form of square root of 50. I hope you understand what I just explained. Okay, now, what if you are given a simplified form of a surd and then you are asked to find the square root of a single number? What do you do? Now, this is what I mean. What if you are given, let's say, you are given this 3 root 5. Look up. What if you are given 3 root 5 and then you are asked to return it back to its original form? What do you do? Now, remember the rule. We said that a root m is equals to, when this a is pushed in here, what do you get? You get what? A squared times m, right? So now, if you are given something like this and you are asked to convert it back to its original form, what you are going to do is you move this 3 inside here. So you're going to have square root of what? 3 squared times 5, right? And that will give us what? Square root of what's 3 squared? 9 times 5. And 9 times 5 gives us what? Square root of 45. So that is how to return this back to the square root of a single number. I hope you understand this. Okay, let's take some classical example together. Now we have a problem here. The question says, express the following as the square root of a single number. Express the following as the square root of a single number. Number 1, 2 root 3. Number 2, 3 root 10. Number 3, 5 root 7. And then number 4, 2 cube root of 7. Now let's solve these together. Okay. The first one is what? 2 root 3. 2 root 3. So remember, let's state our rule. A root m is equals to what? When a comes in here, you get what? A squared times m. So let's apply it here. So we're going to be having square root of 2 comes in here, you have what? 2 squared times 3. So this will give us what? Square root of what? 2 squared is what? 4 times 3. And this will now give us square root of 4 times 3 is what? 12. So that's the answer for the first one. I hope you get that. Now, number 2. We are asked to find this, express this as a square root of a single surd, 3 root 10. So applying the same rule here, so we're going to be having, when we push this 3 in here, we have 3 squared times 10. So this will give us square root of what? 3 squared is what? Is 9 times 10. So this will give us square root of what? 9 times 10 is what? Is 90. And that's the answer. I hope you get that. Okay, number 3. We are given 5 root 7. 5 root 7. So applying the same rule, when we push this 5 in here, we're going to be having 5 squared times 7. So that will give us 5 squared is what? 25 times 7. And then 25 times 7 gives us what? 175. 175. You can confirm that. Okay. Then finally, number 4, we are given 2 cube root of 7. Remember the rule that a cube root of m is equal to, no, when this a is pushed in because of the cube root, it becomes what? Cube root of a cube times m. Remember, we established this in our first lecture. So when we apply this concept here, we are going to be having cube root of 2 raised to the power of 3 times 7. And this will give us cube root of 2 raised to the power of 3 is what? Is 8. Then times 7. So this will give us cube root of 8 times 7 gives us what? 56. I hope you understand what I've explained so far. Okay, we've come to the end of this particular lecture. Let me give you something to play with. Now I want you to attempt this problem. Simplify the following. Square root of 20, square root of 84. So just attempt this and then pause the lectures, look at them, and then in the next slide you can see the answers to verify your answers. See you in the next class. In our next lecture, we're going to be looking at the concept of addition and subtraction of surds. See you in our next class. Thank you.